A man launches his boat from point A on the bank of a straight river 4 kilometers wide and wants to reach point B 3 kilometers downstream on the opposite bank. There's a nice, pretty picture in WebAssign if that makes it easier.
Yes. If you want to share your screen, you can. If you want me to look it up, I can look it up.
Yeah, let me go.
It's up to you. Okay, so launches his boat from point A. So let me copy the graph. So he's at point A, and okay, 4 kilometers wide. Okay, so we have here 4 kilometers, and we have here C, and wants to reach point B. Okay, he wants to reach point B, which is 3 kilometers downstream on the opposite bank. So I'm assuming that between C and B there are 3 kilometers. Okay. As quickly as possible, see the figure below. He could row his boat directly across the river to point C and then run to point B. Okay. Or he could row directly to B. Okay. Or he could row to some point D between C and B and then run. Okay. If he can row 6 kilometers an hour, okay, and he can run 8 kilometers an hour, okay. How far in kilometers downstream from C should he land to reach B as soon as possible? We assume that the speed of the water is negligible, okay. Good. So there is no friction, in other words. Nobody's slowing him down. It's based on example 4, blah, 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 blah. Okay, fine. So you can stop sharing now. Awesome. So in this particular problem, we want to minimize or find the minimum of what?
Time.
Awesome. Awesome. Yes. We want to minimize time. So time is the issue here. Perfect. Okay. So we are going to look at a particular instant, not this and not this. Okay? We're going to say, okay, so he goes from A to D, and then he has to run to B. Okay? So the question is, where is D for a minimizing for minimum time? Okay. So first of all, let's look at the distance. The distance between A and D. I'm going to call this X. I'm going to call this Y. So the distance X has rate times time, assuming uniform motion. So I don't know what this X is. I only know that this is 4 kilometers, and I know that this is 3. Okay. So X is rate times time. The rate we know, it's 6 kilometers an hour because he is rowing, right? So X will be 6 times time. I'm going to call the time for AD time T1. Then Y is also rate times time, but his rate is 8. I wrote 8. Okay,
correct.
yes, 8.
Kilometers.
Very good. Times time T2. And what is the time? Total time. Total time is T1 plus T2. So how I'm going to write it as T, uppercase. T1 is X over 6, and T2 is Y over 8. Okay, now I have the same problem like before. I have 2 variables, so one of them has to go away. So let's see how we make one of them go away. Perfect. Let me go to page 13. Okay. So I have to express, so this is my x. I'm gonna draw it again here so I don't have to go back there to the previous page. This is x. This is 4. And all this is 3. So this was A, this was C, this was D, and this was B. Okay. So how do I express, and this is why. I have to come up with something for x. Well, x from here is going to be, from this right triangle, is going to be x squared equals 4 squared plus this squared. But this squared is 3 minus y. So x squared equals 16 plus 3 minus y, everything squared. So x is the square root of 16 minus 3 plus 3 minus y squared. That's all I needed to do. Just plug it in. And now this is a function of y only. So I have the square root of 16 plus 3 minus y, everything squared, over 6 plus y over 8. That's all I needed for now. A function that represents time, because I want to minimize this, function of whatever variable but just one. From this point on, all I need to do is, you know the whole thing, t prime, yada, 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 yada. So I'll put 1/6 in front, and I will differentiate this. 1 over 2, the square of 16 plus 3 minus y, everything squared, times the inner function prime. 16 prime is 0 plus 2, 3 minus y to 2 minus 1 times negative 1 plus 1 over 8. So let's do this one more time. 1/6 in front, because I don't want to involve this by any means. I don't care for it. Can wait patiently. But then I have to differentiate the square root, which is 1 over 2, the square root, times the inner function prime. But this is 0, plus, I differentiate this. 2, 3 minus y into 2 minus 1, times the inner function prime. And this is easy. Y over 8 prime is 1 over 8. Now, this can never be undefined, because this cannot be 0. So t prime of y equals 0. Ugly. That's not a friendly situation. I will simplify the 2's. And let's see what we have. Y minus 3 over 6, the square root of 16 plus 3 minus y, everything squared, plus 1 over 8 equals 0. Gee whiz. Okay. So now, I have to move 1 over 8 to the other side and cross multiply. Just thinking for a second, I don't want to get a negative number. So I'm a little bit concerned. So let's see. Y minus 3 over 6, the square root of 16 plus 3 minus y, everything squared, equals negative 1 over 8. Now I cross multiply. So I have negative 8y plus 24 equals, so I incorporate the negative already, equals 6. The square root of 16 plus 3 minus y, everything squared. Could they have come up with a even more difficult equation? Okay, so let me make sure I'm on the right track here. So I incorporate the negative in here. That's negative and that's positive. And then this is okay. So far, so good. We'll see what we get in a moment. Can we approximate or not? Do they say anything about any approximations?
No,
No.
I'm rereading again just to make sure.
Uh-oh. So they want an exact answer. Okay, it better be. Okay, this side. I'm going to write it like this for a moment. But the other side is 36 and then 16 plus, I'm going to square this, 9 minus 6y plus y squared. 9 minus 2 times the first times the second, that's okay. Now I'm here. So I have 64y minus 16 times 24y plus 24 squared equals 36 times 16. No, I'm just gonna add first 25. Well, it changes into a polynomial, so that's encouraging. So 25 minus 6y plus y squared. Okay. Okay, we just have to rearrange this, and I need to multiply these times 24. Okay, so I have 64y. Oh! So I have 64y squared, because it has to be y squared, minus 384y plus 24 squared, 576, 30, what is it, 36 times 24. I said 25 and I wrote 24. Nobody knows why. 25. So 25 times 36, 900. Okay, now 36 times 6, that's negative 96y plus 36y squared. Okay, this is encouraging because it changes into a quadratic, but we'll see. So I did 36 times 25, that's correct. Again, 36, yeah, 36 times 6. Oh, look at that. 36 times 6, yes, of course, 216. I'm rushing to finish the problem, and don't let me make any errors with these numbers. Numbers mess me up sometimes. So again, 36 times 6, and then 36. I think I'm okay so far. Let's see now. 64y minus 36, it's 28. Yes, that's 28. Now what do we have here? 384. We are bringing positive, so minus what? So that's an 8, that's a 6, and that's a 1. Please catch my mistakes here. I don't want to make a...
That's what I got.
Okay, so minus, so keep an eye on this. So, and then 576 minus 900. So negative 324. Okay. Now, can I divide all this by 28? It will be nice. 168 divided by 28. Will that work? Oh my goodness. 324 divided by 28, please. No, that's not going to work. Okay, so assuming I did not make any numerical arithmetic errors, I hope, I'm going to go to apps and 9 and polynomial, and this is polynomial degree 2. And then I will punch in 28. I will punch in negative 168. And I will punch in negative 324. Okay. So if they didn't say any approximations, I have to assume that I have to redo my numbers if they don't accept any approximation. So
yeah, there's no approximation.
there is no approximation. So in that case, I have to go back and double check my numbers. Okay, you said
Also, it says that for this question, the textbook has added a challenge which may require an unexpected solution. It just says to look out for that.
okay. So just for 1 second, there are 3 minutes. Everyone can leave in 3 minutes or sooner if that's what you want, but I have to finish this because I started it. So so 6 times t1, and then it was 8 kilometers an hour, 8 times t2. That's okay. So then we have x over 6. X over 6 is t1. And t2 is y over 8. So that is okay. Then this piece is 3 minus y. Yes, 3 minus y, correct. So x squared equals 16, 3 minus 1, that's correct. I didn't put plus or minus because this is distance. So that is correct. So I have it over 6, and I have it over 8, correct. Now I differentiate. 1 over 6, 1 over 2, the square root of this, plus the inner function prime, 2, 3 minus y, times the inner function prime, negative 1, plus 1 over 8. Y minus 1 minus 3, correct, over 6. I simplified the 2, plus 1 over 8. Y minus 8, negative 8y, plus 24, equals this. And I have to square both sides. Okay, so 8 times 8 is this, minus 16 times 24 times y plus 24 squared. That's correct. This is 36. And 16. 9 minus 6y plus y squared. That's correct. Let me check all my numbers again. I don't see any error so far. So 2 times the first times the second. 16 times 24. That's correct. Yes. 24 squared, we already know that, but yes, we know that. 36, 16 plus 9. Yes, it's 25. Minus 6y plus y squared. Correct. 36 times 25. 900 minus 36 times 6. Yes. And plus 36y squared. 64 minus 36. 25. I'm sorry, of course, 28. 384 minus 216. Yes. 576 minus 900. Yes. I don't see any error. So x was 6 times t1, y. Was this 8 kilometers an hour? Can you confirm that?
Yes.
Okay. So this is 3 minus the whole thing minus y. Yes, that's correct. And this is the hypotenuse. Yes, that's correct. So it's 16 plus that squared. That's correct. So the time is x over 6 plus y over 8. I don't see any error. Y minus 3, 1 over 6. And this is correct. 1 over 8, negative. So minus and plus. And then this is correct. And then when we squared, I don't see any error. But if they don't say anything about approximations, they will not like, let me just copy this for a second. Of course, x cannot be negative. So x is 7.5 kilometers. But it doesn't make sense. It doesn't make, yeah, it could. So, yep, hold on one second. So what I got was, that this is 4. So this was 4, right? 4 kilometers, yes, it was 4. So I got that this is 7.5. This is 3. I just want to say that, see if even if it's if it makes any sense. So let me find y. If x, I want to find y. If x squared, so 7.5 squared equals 16 plus 3 minus y squared. I want to find y. This is the y. So 7.5 squared minus 16, and I take the square root to get 3 minus y. So then y equals 3 minus this. Okay, so I just want to find this number. 3 minus the square root of 7.5 squared minus 16 and close. Okay, so I do have an error because my y is negative, so that's not possible. Okay, so now I'm convinced that I have an error somewhere. Okay.
So the problem is asking for the final measurement as the kilometers from C. I don't know if that makes a difference. I guess that is your y there.
No, my y is this.
Okay.
So I know it's asking from this, but I can't have a negative number. 7.5 squared. 7.5 squared equals 16 plus 3 minus y squared. So 7y minus that, and I take the square root, so this is y equals 3 minus that. And I can't, let me see how I entered it. I entered it correctly. Yes, so I can't have y to be negative 3. So I do have an error. So let's look at, just make sure the numbers are okay. So